All right, everybody. We are now ready to move on to the rest of the axial skeleton, having covered the skull. This video is going to be a little bit jumpy because I have to be up walking around to use our lovely one-armed model here. The first thing that we are going to do is talk about the general layout of the vertebral column and rib cage and things like that. And then I'm going to put this thing back on the tripod and we're going to look at actually some of these bones up close to learn the important features that we need to know. Okay, so we are going to start with the spinal column. Okay, and your spinal column consists of many vertebrae, which can be broken up into four basic groups. Okay, up here at the top, the neck, we have the cervical vertebrae. Okay, that's what cervical means, neck. And we're going to talk about their general features here in just a minute. Then we get down to the rib cage, and we have 12 thoracic vertebrae. So 7 cervical vertebrae, 12 thoracic vertebrae. When you lose the ribs, you get down into the lower back. That is going to be your lumbar vertebrae, and there are 5 of them. And then finally, you get down into the pelvis here. The back of the pelvis consists of a series of 5 fused vertebrae called the sacrum, and hanging off the sacrum right here is the tailbone or coccyx. Okay, and that is 3 to 5 vertebrae that are fused together. Okay, so we're going to talk about the features of these vertebrae here in just a minute. I'm going to continue the general overview of this while I've got the phone off the tripod. Okay, so here is our skull. Just to the inside of the skull, and it's difficult to see here without removing the mandible, but there is a bone right here. Okay, the jaw is just straight up in the way. We're going to see this bone here in a minute, but it kind of sits just below the jaw. At the top of the larynx, okay, which is your voice box and the opening to your trachea. That bone right there is called the hyoid bone. So we're going to see the hyoid bone on its own here in a minute. Contrary to what it's kind of showing there, it just has to be mounted to something. Your hyoid bone is the only bone in the human body that does not form a joint with any other bone. It's just hanging out in there, suspended by a bunch of muscles and ligaments. Okay? So now we're going to talk about the rib cage, and we're going to start with the sternum. Okay, the sternum or breastbone consists of 3 bones forming a line here. The top bone is called the manubrium of the sternum. Okay, the manubrium has joints with the clavicle or collarbones here, as well as your first rib pair, which we will look at in just a second. Okay, below that we have the body of the sternum. Okay, that's the body that has joints with the rest of the ribs. And then hanging off the body, you have a piece of bone and or cartilage called the xiphoid process. Okay, the xiphoid process kind of protects the top of the liver, and it's an important diagnostic and landmark point for doing CPR. Okay, so in terms of the ribs, all you really have to know about them, aside from the first rib up here, is the only one you'll have to identify on its own, and we'll see it in just a second separated. You have 12 pairs of ribs, okay? 12 rib pairs, or at least normally people have 12 pairs of ribs. There's a lot of variation in the human skeleton, a lot of other ways things can be arranged, but it's not typically common. These ribs can be broken up into 3 basic groups, and you don't really have to know these for the lab test, but it will help out in lecture. Your first 7 rib pairs, okay, first 7 rib pairs are called true ribs, okay, vertebrosternal, because they connect from the vertebrae back here on the thoracic spine. They wrap all the way around, and each one has its own individual band of cartilage called the costal cartilage, which is going to connect it to the rib cage here, or to the sternum rather. Okay, so those are your rib pairs 1 through 7 are your true or vertebrosternal ribs. Okay, when we get down here, okay, pairs 8 through 10 are what we call false ribs or vertebrochondral ribs. Okay, these guys, these 3 right here, all come together to form a single band of cartilage which loops up and connects just above the xiphoid process. Okay, the reason for that, the reason your sternum doesn't just go down even further, your rib cage is supposed to protect your vital organs, but you don't really want to lose flexibility and mobility. So if you were to heavily armor yourself like that, you wouldn't really be able to bend over at all. Okay, so this is a compromise which still protects the vital organs like the liver, the heart, and the lungs, while still maintaining flexibility at the waist. Okay, and then we have our final two rib pairs. Okay, 11 and 12. They are called the floating ribs or vertebral ribs because they do not connect to the sternum at all. Okay, they just kind of terminate with a little piece of cartilage out there in the body wall, and they are designed to protect your kidneys, which are just kind of hanging out back here. Okay, so that is your axial skeleton layout. Now let's start looking at the actual bones. All right, so the first thing that we are going to do is learn about the vertebrae themselves. There are a couple of vertebrae that you will need to be able to identify by name. The rest of them you will just need to know in terms of their general features, okay? So let's talk general pieces first, and then we'll start going through the individual types. We're gonna go with a nice generic thoracic vertebra here to talk about the parts of the vertebrae. So your vertebrae consist of the central thick portion called the body, okay, vertebral body, and that's designed to be load-bearing, okay? It's got big, thick, heavy-duty bone. It would be separated by the intervertebral discs, which are made of fibrocartilage. Okay, we also obviously see the hole in there. That is the vertebral canal or vertebral foramen. So you've got the body, and then you have the arch, okay, the vertebral arch. Vertebral arch is made up of two basic pieces. Connecting the arch to the body, okay, the bases of the arch are called pedicles. So you've got two pedicles at the base of the arch that forms the sides of the vertebral foramen. And then you have the rest of the arch itself where it curves over. That is called the lamina. So body, pedicles, lamina are the main pieces of the vertebrae. Okay? From there you also have processes. Okay? And there are three main processes that we need to know. Off to the sides, we are going to have the transverse processes. Okay? Transverse processes are points for muscle attachment for muscles like the erector spinae and things like that that kind of help pull up on the spine and keep you upright. Okay, in the middle, we also have a spinous process. Okay, and if we quickly just, if we move this thing up here, we look back at this guy, okay, we can see how the spinous processes all line up and run down the middle of the back. Okay, so transverse processes go off to the side, spinous processes run down the middle. Okay, what we will also see if we look at this from the side, okay, above and below, we see articular processes, and that is where our vertebrae come together to make joints with each other, okay? Those articular processes are gonna be not something you have to name by name, but they're important to understand in terms of figuring out what type of vertebrae these things are, okay? So this is a thoracic vertebra. It's kind of the most generic type. Your other types are the lumbar, okay, lower down, much bigger and heavier duty, and the cervical, which are generally smaller and lighter and are up there in the neck. Okay, then of course you've got your sacrum, which we'll talk about in just a second, and the coccyx, the tailbone. Okay, so we're gonna start with our cervical vertebrae, and more specifically, we're gonna start with the two cervical vertebrae that we need to know by name. Okay, and they are cervical vertebrae number 1 and 2, and they are at the very top of the spinal column at the base of the occipital bone. Okay, cervical vertebra number 1 is a very interesting and unique looking bone. It is the only vertebra that does not have a body. Okay, remember the body is this big, thick, rounded portion that is load bearing. Well, this guy doesn't have one. Okay, this thing is cervical vertebra number 1, also known as the Atlas. Okay, Atlas was the Greek god that I guess held the world on his shoulders. You've probably seen the statue. And that's basically what this bone does with your skull. Okay, your occipital condyles are gonna sit into these occipital fossa on top of this thing, and that's what's gonna allow you to like nod your head up and down. Okay, remember the occipital condyles are kind of shaped like the feet of a rocking chair. Okay, so that is the Atlas, cervical vertebra number 1. The reason it doesn't have a body is because it fits down over the peg-shaped process coming out of the axis, cervical vertebra number 2 down here. Okay, so the axis is also very unique looking. It does have a vertebral body, but on the upper surface, you've got a big kind of thumb-shaped process sticking up. That is called the dens, okay, the dens of the axis. Okay, so what it does is it fits into this opening where there would normally be a body here on the atlas, and that forms a pivot joint. Okay, so we talked a little bit about pivot joints in lab this week, for those of you who were there. Basically, you've got a ring-shaped ligament called an annular ligament that runs around this thing, and that allows this bone to swivel on top of the bone below. Okay, so the joint between the atlas and the occipital bone allows you to nod your head up and down. The joint between the atlas and the axis, that pivot joint, allows you to shake your head left and right, okay? So that's the axis, cervical vertebra number 2, okay? What you need to know about it is just that dens and be able to identify it by its unique shape, okay? Now, cervical vertebrae in general, if I could find my example here, are very easy to identify. They're the easiest of the 3 main vertebral styles to distinguish because they've got extra holes, okay? Cervical vertebrae tend to have a very large vertebral canal because the spinal cord is very big, high up in the spine. And then as it goes through the spinal column, more and more nerves have exited, and so it shrinks. But up here at the top, the hole is very large. This guy has 3. Vertebral foramen in the middle, and then 2 transverse foramina on either side. Okay, the transverse foramina are basically form a channel through which the vertebral artery runs up into the skull. Okay, so if you see 3 holes, okay, those holes are the transverse foramina, and that means this has to be a cervical vertebra. Okay, what you will also often see on these, and I think it's labeled in your book, is a spinous process that is split at the end, or bifid. Okay, that means it's forked. Okay, that forked process is to allow these things to kind of lay over the top of each other in order to let you look up. Okay, you don't see that in the other parts of the spine because they don't have that much range of motion. But these guys, if you want to look up, which is hyperextension of that joint, okay, they need to have a little gap to fit in over the top of each other. Okay, but that is a cervical vertebra, very easy to identify. Basically what that would look like on the test is there would be this guy sitting out here, there'd be a card and it would say, identify the type of vertebra, okay? And you would say, that is cervical, and you would get your 2 points, okay? And then maybe there'd be another one that was like a pin in this hole and it says, identify this hole. And you would have to say transverse foramen, okay? Transverse foramen, spinous process. Probably not going to be asked the transverse processes on these because they're kind of weird because they got holes in them. Probably see that on a lumbar or a thoracic, okay? So that is our cervical vertebrae, right? And I'm going to actually try and tilt this down a little bit more so we can get a more of a bird's eye view here, okay? So cervical vertebrae, okay? Here we have a thoracic vertebra. I'm actually going to zoom out a little bit too. Okay, thoracic vertebra, pretty generic, no extra holes. They can be identified on real bones by the fact that there is a rib facet coming in on the backside of the transverse process. Those don't really show up on the plastic ones, so that's not your best bet in terms of identification. When you get down to your thoracic and lumbar vertebrae, there's a couple of tricks you can use. Okay, lumbar vertebrae, the bodies tend to be much more massive. Okay, your thoracic vertebrae, A, they're carrying less weight because they're higher up on the body. B, because of the rib cage wrapping around to the front, it has a little bit better weight distribution. When you get down to the lumbar spine, okay, which we can see on our model up here, there's no ribs anymore. Okay, when we get down to this area, there are no more ribs to help support it. And so you're going to see some changes in the structure of those vertebrae. Okay, so let's talk about your lumbar vertebrae. Massive vertebral body for weight distribution, comparatively small vertebral foramen because your spinal cord is shrinking as you go down, okay? And one of the main things that we will notice is this blunt spinous process, whereas with your thoracic vertebra, it's kind of pointier. And then the articular processes, which again, you don't have to know by name, but they are useful for helping distinguish between these two. Your articular processes on these things are huge. They're very robust, which helps them fit together and help distribute that weight, because again, that's where all of your weight is running down into your hips, okay? So we can distinguish these from each other. The easiest way I have found is to just look at them head on like this. Your thoracic vertebrae, both of these kind of look like animal heads. Your thoracic vertebrae kind of look like a giraffe, okay? Long pointed snout, wide set ears, and the two little horns that giraffes have on top of their head. Your lumbar vertebrae, due to the blunt spinous process and the combination of very wide transverse processes and heavy duty articular facets on top, as well as the low hanging articular facets on the bottom, this kind of looks like a moose, okay? Blunt snout, the jowls that moose have, moose. And then like these pieces up here would be the antlers, okay? So if it looks like a moose, it is lumbar. If it looks like a giraffe, it is thoracic. If it has extra holes, it is cervical. And when you get to the interface between like T12 and L1, okay, so up here in the spine, where your rib cage ends and the lumbar spine begins, they start to look a little bit more similar. Those are not the ones I'm going to give you. I'm going to give you like L5 and T3 or something like that, some that are very different looking from each other. Okay, so that brings us to the base of the spinal column, which is the sacrum. All you really need to know about the sacrum is that it is the sacrum. Okay, it makes up the back of the pelvis, again, as we can kind of see on our model right there. Okay, there is your sacrum and coccyx in between the two os coxa or hip bones. Okay, so sacrum, not all that remarkable. Its curvature is interesting, but that's something we'll talk about in the lecture class. And then we have the coccyx itself, the tailbone. Again, 3 to 5 fused vertebrae. These do not move, okay? This is one big solid piece of bone that results from 5 vertebrae fusing together. Same basic story with the coccyx. It's just a little bit more variable, okay? So now we're gonna go ahead and look at the front side of this. And first we're gonna talk about the hyoid bone. Right? Again, the hyoid bone sits at the top of the larynx, just at the very top of your throat, right below your lower jaw. And this bone essentially keeps the larynx open, as well as kind of making up part of the floor of your mouth, like the base of your tongue and things like that. Right? So just all you have to know with the hyoid is that this is the hyoid. It doesn't really look like anything else. It doesn't have joints with anything else in the body. It's just the hyoid bone. That's all there is to it. Just a little horseshoe-shaped bone. Okay? So, the ribs themselves. There is one rib that you will need to know by name, and that is this one. That is the first rib. It does not look like any of the other ribs. Okay? It is very flat. Okay, so the first rib connects to the manubrium of the sternum, which is the upper piece of the sternum. All the rest of the ribs, okay, look like that. Those are just ribs, right? That's all you'd have to know about them. So first rib is the only one you have to know by name, right? So I believe that concludes our axial skeleton. Now I am going to review the appendicular skeleton. I will probably do it one limb at a time, so there will be a total of 4 videos to go over this stuff for you guys.